right. So today's warm-up is not even really a review of the last lesson, but a couple lessons ago. So number one, we're going to actually figure this out by survey. Give me a thumbs up if you think that the two lines are parallel. Thumbs up if you think they are parallel. Okay, so nobody's put their thumb up, so nobody thinks they're parallel. Could someone explain why they are not parallel? Got a lot of people. We'll start with Shelby and then Sebastian. What do you think? Okay, what were you going to say? Okay, can you tell us what the slopes were? Very good. Excellent explanation. And so, no, the slopes are different. One slope is 5 and the other is 1/5. Number 2, I asked you to graph the equation. Here is what your graph should have looked like. And here is the equation in slope-intercept form. I put the y-intercept on the graph just so you could see it. So number 2, I asked you to graph this using the slope-intercept form. Give me a thumbs up if you did do the graph using slope-intercept form. Put your thumbs down. What did you do?
Mine just I was finding the x-intercept form. I would just replace y with 0, and if I was finding the y-intercept, and then I would just replace x with 0.
Okay, so you didn't do slope-intercept form. You did the intercept method. Okay, what did you do, Alyssa? Okay. You don't seem certain.
I'm not completely sure.
Well, let me back up. Did you get the correct graph? Okay, well that's good. So you must know how to do it.
Yeah.
So you're just saying you don't know what the name of the method is? Okay, there's 3 methods. Could someone tell me the first method that we learned? First method, Zabari? Table of values. What was the second method we learned? Eric knows. Go ahead, Eric. It's the one you just explained that you did. What's the second method called? Right? Using intercepts. And what's the third method called, Ania? Slope-intercept form. So those are the 3 methods. You need to know which method is which. So I'm glad that Alyssa and many of you were able to graph, but it is also important that you know what you did. Okay? Now, Eric, I asked you to graph using slope-intercept form, yet you didn't do that. What made you think that there was a better way to do it? Oh, so you messed up. Okay, but you still got the right graph? Well, isn't that interesting? Now, would I be able to tell who did which method just if I looked at your graph? No, because everyone should get the same graph no matter what method they used. So even though I was specific and I did ask you to use slope-intercept form, I would never know unless I looked at your work. Okay? That's something to keep in mind as we move to the latter stages of chapter 4 and start reviewing. Okay? Yes, Sheree.
Okay, actually there is like a way to tell like what you did just by looking at a graph. If one of the points is on the x-axis and if one of the points is on the y-axis, then you know the person used slope-intercept.
Possibly, yeah. Possibly. But how would I know that they didn't use the slope to go from here all the way to there? Okay? So, any comments or questions on the warm-up? Comments, questions, concerns? Anything at all? Okay? Thank you. Today we're going to discuss the concept of functions and relations. And specifically, we're going to talk about something called function notation. Before I begin talking about the terminology, I'd like to direct you to the back. And my concept map, I want you to notice that chapter 4 is going across the middle, and the last piece that I put up, chapter 4, was direct variation. Well, that's the concept we did last time, so why do I not have function notation up here as well? I put this map up here to refer to so that I can point out any time that we have a concept that we're learning presently that's connected to a concept in the past. So, for example, when we did slope-intercept form, that was directly related to literal equations when we learned function form. So these two were closely connected. But there are a few concepts throughout the year, not a lot, but a few throughout the year, that are introductions to something you're going to use 2 years from now. So I'm going to introduce something to you today. You have to know it. You have to understand it. We're going to use it, but you're really not going to be using it full force until you get to Algebra 2. But if I don't introduce it to you this year, when you get to Algebra 2, you're going to be confused beyond the point that's reasonable. So, we are going to look at equations and functions in a slightly different way. It's called function notation. It's a way of naming a function. So, the common letters that we're going to be using today are F, G, and H, and you'll see lots of other ones throughout the rest of the year. So, what we do is we take the letter Y that we're accustomed to using. We have X's and Y's. We take the Y and we remove it, and we replace it with this. Now, based on your experience, that looks like F times X, but it's not F times X. It's something totally new and different. This means the value of F at X, or what most teachers will say is F of X. Again, keep in mind that this is brand new for you, so if it initially doesn't make sense, that is totally normal. So this is read F of X. So for example, we are used to writing this. This is what you're going to see today. F of X equals 19x minus 1. That is the same thing as Y equals 19x minus 1. All we've done is we've taken the we've taken the Y and replaced it with an F of X. So all we have to understand is how it all works. The good news is that you already know everything. There's nothing really new except for this notation. Here's another example. G of x equals 1/2 x plus 15 is the same thing as y equals 1/2 plus 15. So if I asked you to graph this, function, you should find that incredibly easy. Because if you just pretend that that is really a y, then that's easy to graph. So I imagine you have some questions, but I want you to hold off, and we're going to explore some different types of problems, and hopefully you'll start to understand. So, example 1. Evaluating a function that's written in this form. So part A. F of x equals 3/5 x plus 2. So that's the function. and we're being asked to evaluate it when x is 3, and then evaluate it again when x is negative 2. So we're being asked to evaluate the function 2 times. So this is how you write it out. We write f of, and now we replace all the x's with the value of x. So now we're going to say f of 3 is 3/5 times 3 plus 2. So all I did was replace the x's with the 3 that came from right here. Does anyone have any questions on why I put that 3 there?
Why didn't you use the other one?
We're going to do this one first, finish the whole thing, then we're going to do this one. It's basically 2 different problems, okay? So now we just simplify everything. Simplify and we get the value. So f of 3 equals, and now we have to do 3/5 times 3. What do we get with that? Ania? 9/5. Very good. 9/5 plus 2. So what do we get for f of 3? F of 3 equals what? Just 4 people can add those 2 numbers together? 6 people? Sharik?
F of 3 equals 3 4/5.
3 4/5. So you can either say that it equals 19/5, or you could say 3 4/5. And so f of x is 3 4/5 when x is 3. So that's one of the values we were looking for. Now we're asked to evaluate the function again when x is negative 2. So we're just going to follow the same process again. But this time, we're going to say f of negative 2 equals 3/5 times negative 2 plus 2. And just simplify. I mean, the rest is stuff you already know how to do. F of negative 2 equals, so this time we'll get what for that multiplication right there? Hezekiah? Yeah, negative 6/5 plus 2. So what do we get this time? Brian? 4/5. We get f of negative 2 equals 4/5. And that was the second value we were asked to find. Does anyone have questions on how we did that? Comments, questions, concerns? Tristan? Three times 3 is 9. 9/5. Now we have to add 2. You're talking about how did I get from here to here? Is that what you're asking me? Okay, well, rewrite 9/5 as a mixed number. Good. 1 and 4, excuse me. 1 and 4/5 plus 2. 1 plus 2 is 3, plus 4/5 is 3 4/5. No, it's an addition problem. It's 9/5 plus 2. Okay? You see it now? Okay. Kamoy and then Maria.
For the second part, isn't the answer negative 4/5?
No. Negative 6/5, and could someone tell us what is 2 when you make it a fraction with the denominator of 5? Ania? 10/5. So negative 6/5 and positive 10/5. 10 minus 6 is 4. Okay, do you need me to write it out or do you see it in your head? Good. Maria? Same thing? Okay. All right, part B, it's more of the same. It's just a different function. The function g. G of x is -4 times the quantity 2 minus x. And we are asked to evaluate it with these values. So, g of 3 equals -4 times 2 minus 3. This is even easier. It's just all mental math at this point. G of 3 equals what? Kayla? Good. And what's -8 plus 12? +4. You did a little bit the long way, but that's good. You could have just done 2 minus 3 and then multiplied times -4. But you got it. It's 4. So that's one of the values we were looking for. And now we're asked to evaluate the function when it's -2. So, g of -2 equals -4 times 2 minus -2. So what do we get for g of -2? Brandon?
-16.
You get -16. That was the second value we were asked to find. Any questions? Go ahead. Sure. Absolutely. Other comments, questions? So here's the thing. What we just found were really y values. F of 3 equals 3 4/5. That's really saying y equals 3 4/5. This is saying y equals 4. This is saying y equals -16. We're just giving the y a different name. Okay? Any comments, questions about that? Okay, so now we're going to flip it around. And now we want to actually find the x value. Now, I got to tell you that when I read this, it sounds incredibly confusing. Here's what I'm going to ask you to do. I'd like you to copy the full question for part A. You don't have to copy the full one for part B. But it's important to see the instructions because when I send you home, you're going to forget. So you need something to refer to. So it says, for f of x equals 3x plus 1, find the value of x so that f of x equals 10. Wow, that sounds unbelievably confusing. But watch what happens when I make one simple change. I don't want you to do this, I just want you to watch what I'm going to do. So now looking at it this way, can someone tell us what we have to do? What do we actually have to do? Like what's our action steps that we're going to take? Kamoy and then Catalina? Solve it? Well, what do you mean? That's a very broad statement in this classroom. I don't know, what did we do yesterday? I did like 50 different things yesterday. Exactly. We're going to replace the y with the 10. Right? That's all. So we're going to put 10 equals 3x plus 1, and now solve this equation. In fact, you don't even have to solve it. You can do it mentally. Solve this equation for x. But now I want to put back the original way it was written. So I want to put back the original way it was written, so give me a second. So that very confusing statement means take this whole thing and replace it with the 10. That's different than what we did here, where I replaced just the x with the number that I was given for x. That's different. I just replaced the x here. Now we're replacing this entire notation, f of x, with a 10. So we don't even need to use our solving skills. We can just do this mentally. What does x equal in this case? Anissa? 3. Does anyone have any questions? So here's what I see based on my experience. Now I've given you 2 types of questions. My students get confused on which one is which. Wait, am I supposed to replace the x with the number, or am I supposed to, where's the y? And wait, do I replace the x or the f of x? And so all of a sudden, you have 2 different types of questions, and you get confused. So what do you do to help yourself? Change f of x into a y, and then figure out what to do. Okay? Any questions about that? So let's make sure that we understand. Let's look at part B. I told you didn't have to copy the whole thing, but we do need the function. So again, it says h of x equals 6x minus 6. What I see in my head is y equals 6x minus 6. And I see y equals 24. So we'll rewrite the whole thing, replacing the y, or the h of x, with the 24. 24 equals 6x minus 6. And again, this equation is so easy, we don't need to use our solving skills. We can do it mentally. What do we get? Sebastian? You get 5. So x equals 5. Does anyone have any questions on how we did that? Questions or concerns on anything here? Okay, let's see how you do on your own. Checkpoint number 1. You got 2 questions. You got 3 minutes. we get for h of x when x is 0? What do we get for h of x when x is 0? We'll start with Maria, and then we'll go to Hezekiah. Maria, what'd you get?
1.5.
Okay. Okay. Well, okay. That's not what I was looking for. You gave me the second one, but that's fine. So h of 0 is 1/2. H of -3 is 12.5. What about part B? What's the value of x that will make that a true statement? We've got a lot of people who think they know. We'll start with Aliana, and then we'll go to Kayla. The correct answer is 2. Give me a thumbs up if you got both questions correct. Okay, put your thumbs down. Comments, questions on either of them? Comments or questions on either of them? Tristan?
Was it possible to round down? Because I got 2.1 on the second.
It comes out exact. For part B you're talking about? Okay, so we're replacing this whole thing with the 17. So it's 17 equals 7x plus 3. So think of it this way. If I took this, no, that's not going to work. If I took this whole thing away, what number plus 3 is 17? 14. So 7 times what number gives me 14? 2. Okay? Good. Other comments or questions? Okay, we have 2 more scenarios that we're going to explore. This one is going super fast. I'm going to go unbelievably quickly. Graphing a function in this notation. F of x equals 1/2 x minus 4. What does that look like? What does that look like, Alyssa? And that's called what? Beautiful statement. Yeah, it's just y equals 1/2 x minus 4, which is slope-intercept form, and so this is incredibly easy to graph. It takes very little effort at this point. The y-intercept is -4, so we'll go 1, 2, 3, 4 down, and then we're going to rise 1 over 2, rise 1 over 2, rise 1 over 2, and then draw a line through it. Put arrows on either end to indicate it goes on forever. And that is it. Graphing a function. I believe that took us 1 minute. So there is nothing new when you talk about graphing a function in function notation. Does anyone have any questions on how we did that? Because I did go very quickly. Okay, the last skill we need, the last type of question we need to be able to answer is calculating a slope when you're given information in function notation. So we are given that f of 2 is -6 and f of -5 is 8. That looks, to me, personally, looks unbelievably confusing. But I have gotten so used to it, this is what I see. My brain has gotten so used to this notation, this is what I see. And And how do we find a slope, or how do we calculate slope when we're given this information? How do we calculate slope from that? Brandon? Good, that was a beautiful statement. If you can use the way he said it, I like to use the formula, which is the same thing. But what I've always asked you to do, and here's the key part, is I ask you to label x1, y1, x2, y2. And that really helps you not make a foolish mistake when you're putting the information in. So it's y2 minus y1 over x2 minus x1. Mental math. 8 minus negative 6 is really 8 plus 6. Negative 5 minus 2 is really negative 7. So we get 14. 14 over negative 7. So what did it come out to, Ania? Negative 2. The slope is negative 2. Now, how can I do this from this notation without having to rewrite the points? Well, look at the order. Look at the order that information is coming in. The 2 comes first, the 2 is the x, the negative 6 came second, the negative 6 is the y. So let's use that knowledge to take some shortcuts. We know that that's the x, so we'll label that x1. We know that that's the y, so just label it y1. That's the x2, and that's the y2. If you feel more comfortable rewriting it as an ordered pair, that might help a lot of you. But if you feel like you can skip over that step and jump straight to m equals, then just do this. It's in the same order. So y2 minus y1 over x2 minus x1. So what do we get for the slope this time? Anissa? Negative 2/3. Very good. Go ahead, come on.
Remember when you told us that if it has like the negative in the middle, it's like for one of this? Isn't it like for both? Isn't it negative for that one?
Well, this comes out to 0 minus negative 2. Keep, change, change. That's a positive 2. Negative 4 minus negative 1. Keep, change, change. That's a negative 3. And so all I did was take the negative sign and move it to the middle. You see it now? Good, but that was a good question. Okay? Other comments, questions? Okay, let's see how you do on your own. Checkpoint number 2, find the slope of function f. Got a minute and a half. you get for the slope? 1, 2, 3, 4 confident people, 7 confident people, 9 confident people. We'll start with Anne, and then Shelby. What'd you get?
Slope is -9.
Okay. Okay, so we have a bit of a disagreement. What do you think, Sebastian? The slope is -3/2. Unfortunately, Anne, I don't mean to sound harsh, but you must put all slopes, all fractions must always be in simplest form no matter what. If you did put -9/6 on a quiz or a test, I would mark it wrong. It is harsh, but it is the reality. At this point, you should be able to recognize when there is a numerator and denominator that have a common factor. Good. Can someone explain why her answer would also be marked wrong? Because -1 1/2 has the same value as -3/2. Why is this going to be marked wrong and this is correct if they have the same value? Got a bunch of people who think they can explain. Zabari?
Because we're trying to graph it and we can't graph it. So,
Why can't I graph it?
well, you have to do rise and run. There's no rise and run.
That's the key. Is that when you talk about slope, the top number has special meaning, that's the rise, and the bottom has the special meaning of run. So there's more things happening when you talk about slope. So you cannot convert slope into a mixed number, okay? Now the good news, Kamoy, and there's probably other people as well, the good news is you clearly know what you're doing, you just went too far, okay? Good. Maria?
Okay, so you know how the y, the f of 2, that's a y, the secret y.
Yep.
Okay, but is it when we're doing the ordered pair, shouldn't it be x then y? Because if we like, you see how 8 is -7?
Yep.
So shouldn't it be -7 then 8?
It's very confusing. It's no.
Okay.
This is the x, and that's the y. It is extremely confusing. It took me, I want to say, years to figure out why this was the x and this is the y. It's just confusing looking, that's all. So all I can ask you to do is try to trust me. Try to just get it through your head that this is the x and this is the y. One of the biggest issues that my students have is that they flip it around. So you just have to get used to it, okay? Catalina?
Do you know way if it's like a kind of a y, when you do f of x, there's always an x in the parentheses?
That's right.
So that's why I know that it's that one.
That's right, because where it says f of 2 is 2, this is f of x is 2. And so the x is over here. How could that be the x? She thinks it's the x because in her head she's seeing this. But this is different. So this is not what's going on. Okay? Again, it's confusing. There's no two ways about it. It just takes getting used to. And this is one reason why we introduce it now, even though you're not going to use it full force until Algebra 2. All right, we're doing very well today. Draw a line across your paper. Your classwork is page 45. You got 5 questions, number 36, 30, 26, 21, and 11. You got 5 questions. You got 10 minutes. Of course, if you are uncertain of yourself, you have any questions or comments or anything at all, please let me know and I will come help you. No. right, let's see how well we're grasping function notation so far. Number 36. So you should have had two graphs that both started at 0. That should have been immediately obvious to you because these are both basically direct variations. There was one part that I neglected to warn you about where it says, how is the graph of f related to graph of g? I didn't want you to do that. If you did, that's good. It's a skill you need later on, but I didn't want to worry about it right now. Part B, what's the difference between a 12-week membership? It's $24. You could have provided a whole bunch of different explanations, but the difference is $2 per week, and so you multiply 2 times 12, you get 24. The $2 is for the locker, okay? Number 30, remove this. Number 30, you were asked to graph, and number 26, you were asked to graph. And number 21, and number 11. So I'm going to open up the floor for questions. We'll start with Hezekiah and then Kamoy. Well, what were you asked to find in the instructions? Good. Find the value of x so that the function has this value. So could someone explain what you were supposed to do with the 18 to make this work? Alicia? Yeah, you're putting it in place of this whole notation right here. So it was supposed to become 18 equals negative 2.4x plus 6. That was the same situation that we did in example 2. Okay? Kamoy.
I already got, I had the same graph on the
Well, it has to be this, because the y-intercept is negative 1.5 right there. Right here is negative 1.5. That's the y-intercept, and then the slope is 1 over 1, so you had to rise 1 over 1. There's your next point. Draw a line through it.
26.
Which one? 26. The slope is 8 over 1. The y-intercept is 0. Up 8 over 1. The publisher did not provide the best graph of this, but if you go all the way up to 8 and go over 1, there would be a point way up here. What did yours look like?
I didn't know that it was like since the publisher only went up to 3, it was just confusing.
Okay, did you go all the way up to 8? Okay. All right, are there any other comments or questions? Okay. Your homework is on page 269. You're doing numbers 8 through 34 even. Then you're doing 40, 42, and 46. Numbers 24 through 34 ask you to do two things. It asks you to graph, and then it asks you to do something else. I only want you to graph. You'll understand when you see it. On page 272, to make sure we're reviewing. To make sure that we're reviewing concepts from the past, you're doing Ready to Go On numbers 1 through 3. And your test on chapter 4 will be on Monday.